You have already learned that our AI agents or AI automations always have a brain. The brain is an LLM. So if you basically click here, you see that ChatGPT in this case is the brain of our AI agent. I have to tell you right now that we have a lot of different LLMs. We have, for example, Grok. We have the GPT models, we have the Gemini models, we have the DeepSeek models that are open source, we have Quen models, we have Claude models, we have Llama models, and basically a gigantic amount of different LLMs. But in this video you have to learn what an LLM is, so that you understand how the brain of our AI agents is working. It's also important that you understand tokens because you need to pay the tokens that you generate over the API. And we will do it really simple. We will use an open source model just for the sake of this tutorial. As an example, we will use a Llama model as the example, because with these Llama models we can see exactly what's inside. But all of these LLMs, they are trained completely similar. It does not really matter about what LLM we are talking. Basically, they are just two files. And we make just a simple example with Llama 2. For everybody that already knows exactly what an LLM is and how it works, of course, you can skip the lecture. Basically, an LLM is just two files. We have one file, and this file is basically the parameter file, and I simply make it here as P. This stands for parameter. And we have a second file, and the second file is just to run these parameters. I just call it run file. This run file is most of the times written in C. C is a programming language, or in Python. So both of these can eventually work. So what we have right here is the parameter file and the run file. And the run file most of the time is simply 500 lines of code. So we use 500 lines of code to run this file. And this file is where the magic happens, because this file is gigantic. We make an example with an LLM that is open source. And the LLM is called Llama 2. So Llama is of course the LLM from Meta. I simply call it Llama 2. And they have different models. And this Llama 2, where we make this example, this is the 70B model. So this simply means that we have 70 billion parameters. So you know, like, this is a relatively big file that we have right here. This file is basically this parameter file. So this parameter file has 70 billion parameters. And how do we get all these parameters? We need to train this file, and we train it on a lot of text. We use 10 terabyte of text in order to train this file. So we use 10 terabyte text. This is text from all over the internet. So this could be Wikipedia articles, websites, and much, much more. And this file, we can simply compress this file down, and this file is only 140 gigabytes big. So this file is just 140 gigabytes big, and we train it on 10 terabyte of text. So you know, we can compress it down really a lot. This parameter file, you can simply think of this file just like a zip file. It simply compresses down all this data. And in order to compress this data, we need a lot of GPU power. So we need a lot of GPU power in order to compress this data. And that's also why Nvidia was such a great stock over the last years. If you look, for example, at the Nvidia stock, you see we have a gigantic run-up. And this is basically because everybody needs GPUs. So you see we have a gigantic run-up. We basically started somewhere down here. So this was November of 2022. And here comes ChatGPT online. So the normal ChatGPT that most of the people know. And then it was relatively clear that we need a lot of GPUs in order to train these models. And this stock got on a tear. But this is not about stocks right now. So basically, we use a lot of GPU. I make this really simple. I also have more detailed explanations, but I don't think we need this in this course. In this course, we only need to know that we need a lot of GPU in order to compress 10 terabyte of text down into a parameter file. The parameter file is similar to a zip file, so we simply compress 10 terabyte text into a 140 gigabyte file. And this file has 70 billion parameter. the parameter file. And then we have the second file. The second file is the run file. It's just a few lines of code. And if we have an open source LLM, just like Llama 2 or even Llama 3, or whatever open source like that you want, we can download this file and we can run these files locally on our PC, and this brings us maximum data security because nothing goes over the internet. If you use a closed source LLM, the biggest downfall is that you need to use either a web interface or their API, so you can absolutely not download these two files. You cannot run them locally. This is the biggest downfall of closed source LLMs, at least in my mind. And the thing is, with these two files, they are a little bit magical, because here works the transformer architecture in the background. You can simply think about a neural network. We don't need to dive that deep. But basically the neural network sees words and predicts us what next word comes most likely. So it works basically like this. We train on all this text, and so the LLM simply learns how text is structured. If we ask, for example, what should I eat today, the LLM will simply predict what words a human will most likely hear. So this is simply called the pre-training. And with the pre-training, we simply hallucinate stuff out of this file. But then comes the second thing. The second thing is the fine-tuning. And with the fine-tuning, we give the LLM a lot of examples how humans want to have their response. So we would feed, for example, a question, what should I eat today? And then we would feed an answer that humans like. For example, you could eat steak today. And if we feed this over and over and over, the LLM learns how humans want their responses. This is called the fine-tuning, and this is the second part in order to run LLMs. And of course, on open source LLMs, we can even fine-tune ourselves, because we get access to these base models, to these pre-trained models. And then the last part is the so-called reinforcement learning, and we can break this down really simple. After the pre-training and the fine-tuning, we will simply do this reinforcement learning. This basically means that we ask a question, we get an answer, and then we tell the LLM if this is good or not. This is basically the reinforcement learning. So we have three phases of training. The pre-training, we simply use a lot of GPU to compress a lot of text down into a smaller so-called zip file, and we can hallucinate text out of these. In order to make these hallucinations better, we do the fine-tuning. So we feed a lot of questions with answers structured in a way that humans like. And in this phase, the LLM learns how humans want the responses. This is a lot cheaper, we need less GPUs, we do this with roughly 100,000 examples. So the pre-training 10 GB of text, the fine-tuning only 100,000 examples and a lot less GPU. And lastly, the reinforcement learning, we simply take a look, hey, makes this sense or not? If yes, thumbs up, if no, thumbs down, and the LLM will simply learn further how we want our responses. Now the next thing that is really important is, you have already learned it, in this transformer architecture there are neural nets. And neural nets, they work with weights, basically they work with numbers. And in order to make sense for the neural net, of course, we need to have numbers. So the first thing is, of course, if we feed a question into an LLM, the LLM will make numbers out of these questions, the so-called tokens. These tokens are numbers, and with these numbers the neural net can make its calculations what word will come most likely as the next word. So I want to show you simply how these tokens are structured. If we go on this tokenizer, we can see it. We can simply type in, what can I eat today, for example, and now you see we have 5 tokens, 20 characters, and the tokens are structured in this way. And if we press here on token IDs, so this is basically what the LLM sees. The LLM sees numbers, and with these numbers the neural net can make its calculations and gives us a good response. If I press right here, for example, on clear once again, Then go on show example, you see a bigger example. And here you also see that not every single word is one token. This gets divided a little bit different. So here you see invisible is for example 2 tokens, and here this point is also a separate token. So we have a lot of different tokens, and if we press on token IDs, you see this is basically what the LLM sees, and the LLM makes its calculations out of these tokens. But why I show you this? Because this is important, because we have a token limit. Every single LLM has always a limit how many tokens it can understand right now. If we go on this article right here, what are tokens? OpenAI tells us that a token is roughly 4 characters in English. It means that 1,500 words are roughly 2,048 tokens. And this is important because every single LLM has a different token limit. You can see it down here. Right now, at this minute, GPT-4 Turbo and also GPT-4 Omni and a lot of other models, they have roughly 128,000 tokens as token limit. We have also models that have 2 millions in token limit. We have also smaller open source model that have only 4,000 tokens as token limit. And the important stuff is that you understand that as soon as this token limit is reached, the LLM will no longer understand the things that you talked previously with the LLM. I just want to show you an example into ChatGPT. I simply tell the LLM, write a story about a fox, and now our first tokens get generated. And as soon as we are close to the token limit, so as soon as I talk, for example, about other stuff right now, let's just assume that I want to have different stories right here in this chat. For example, tell me a story about a frog. Right now, of course, new tokens get generated. And as soon as we reach our token limit, the LLM will no longer know our previous question and also not the answer, because the LLM always just knows the last few tokens. In this case of ChatGPT, the context window is relatively big, so it knows 128,000 tokens. These are roughly like 100,000 words, roughly, like I said. And after it, it will no longer get what we talked previously. So please remember, always the last few tokens count, and everything that is over it will no longer be in the knowledge of the LLM. You can call it this way. Of course, we have a lot of techniques to increase this knowledge, for example, direct technology and so on. We will talk about this later. But for now, you need to understand that every LLM has a token limit. Eventually, this will go away. Eventually, the token limit will be so big that we no longer need to think about it. But right now, at this minute, we have these limits and we need to know this. So basically, if you ever wonder why the LLM no longer knows what you talked about previously, it's simply because the token limit is reached. And we have a lot of techniques to make this work a lot better, and of course over this course you will learn how. Another concept that you need to understand is, as soon as you are generating these tokens over the API from OpenAI, you need to pay. You need to pay for every single token. But more on that, of course, in the next video, because in the next video I want to show you exactly how the OpenAI API works and how much you need to pay. And if you use open source models, of course, you can generate these tokens on your local machine without paying anything. So in this video you have learned how an LLM works. Basically, we have just 2 files. We have a parameter file and a run file. The run file is just some code to run the parameter file. And the parameter file is simply a lot of text from the internet, but it is compressed down into a small file similar to a zip file. We need a lot of GPU to do this. This was the pre-training. After the pre-training comes the fine-tuning. Here we feed the LLM questions and answers so that the LLM can learn how we want our responses. And after the fine-tuning, the final step is the reinforcement learning. We simply ask questions, get answers, and rate the answers if they are good or not. And with this last phase, the LLM will get better at these tasks. Then you have also shown that in the background works the transformer architecture. These are neural nets, and neural nets, they make calculations with numbers. And that's why we need to divide our words in tokens. And with these tokens, we can make the calculations and calculate what word comes most likely as the next word what we want to have. And you need to understand these tokens because every LLM has a so-called token limit. And as soon as the token limit is reached, the LLM will no longer know about what things you talked previously. It always looks at the last few tokens, and of course this token limits is the model dependent. Sometimes it's 4,000 tokens, but it can go up until 2 million. Of course, I will always tell you what model has what token limit. With all these open source LLMs, we can run these things locally because we can download the run file and the parameter file. And with the closed source LLMs, we can not do that. And one last thing, of course, it's really important what questions we ask the LLM, because with good questions, we get good answers. This is called prompt engineering, but more on that, of course, later. And I see you in the next video. I know we did this a little bit fast, but I think these technical details, everybody should simply have a grasp of this. So we did it fast, we did it not in complete detail, but this is more than enough to work with these models.